All right, this is Algebra 1B, section 10.4, day 2 on graphing square root functions. First example looks like this, and the transformations are to shift it left by 2 because of the x plus 2 inside the square root, and to go down by 5 because of the minus 5 at the end. So my parent function always uses these points. If I plugged it into just the regular y equals square root of x, I like these values because I can take their square roots and get those nice integers. But in the reality is, in the problem that we have, we're supposed to take these points, go left by 2, so subtract 2 from all of the x's, and then go down by 5. So subtract 5 from all of the y values. And now these are the points that we're going to put onto our graph. -2, -5. This is my first point, so I like to make it bigger because this is going to be our launching point. -1, -4, and 2, -3. So starting at my first point, I want to hit those other ones, and there's my graph. The domain is going to go from -2 to infinity. That's my farthest x point to the left. And my y value is going to go from -5 up to infinity, my lowest y value when it's going all the way up. Number 2, transformations for this one. So in this one, we're going to be going right by 2. Then we have the -1/2 here. This is going to be a vertical shrink by 1/2. The negative sign is also going to reflect it across the horizontal or x-axis, at least temporarily. And then at the very end, the last thing we'd have to do is shift the graph up by 4. So once again, I'm going to use my parent points, 0, 0, 1, 1, and 4, 2. And then those transformations that were listed. We're going to go right 2 first, so add 2 onto all those x values. And then this, so that's done. This affects the y values. Multiply all the y values by that -1/2. So 0 times -1/2, 1 times -1/2, 2 times -1/2. So that's been taken care of. And lastly, we have to go up by 4. So add 4, and add 4. Oops, and add 4. So these are the points to graph. 2, 4, big point. 3, 3.5, and then 6, 3. So first point, hit those other ones. And what I'm seeing is the vertical shrink, it's not going as fast as it normally would. And then that negative sign made it go down. So it's not actually reflected across the x-axis anymore because it then got shifted up. But this is what our graph is going to look like. The domain goes from 2 to infinity, and the range is going all the way down. It gets to the highest y value of +4. Number 3. This one is going to shift left by 3. Vertical stretch by 4, and it's going to go down 1. I'd pause the video, see if you can keep going without following along with me, see if you can make sense of this, and then check back on it later. I'll go back to explaining how this is done, but again, I'd try it on your own. We've done a couple of examples on this video already. Here are the points from the parent function. Then, doing these transformations, we need to go left by 3, so subtract 3 from all the x's, multiply all the y values by 4, and then we have to shift all of them down by 1. So our points are -3, -1, -2, 3, so it's going up pretty steep, and then 1, 7. So starting point, and it's going to launch like that. The domain goes from -3 to infinity, and the range goes from -1 to infinity. All right, so there's our review on graphing the square roots. Now let's get into simplifying. Square root of 120, square root of x to the 5th, square root of y to the 10th. Again, I go ahead and pause it, see what you can do. Square root of 4 times square root of 30. That's 2 square root of 30. Divide this by 2, we get 2 0.5, and then divide this one by 2, and that's y to the 5th. So then for our final answer, underneath the square root sign, we have 30 and x. Out front, there's a 2, x squared, y to the 5th. Letter B. Lots of little parts to break down in this one. Square root of 4, square root of 15. So that's 2 root 15. Bring down that negative 5. So the very first term is negative 10 root 15. Plus, this is square root of 25 times the square root of 5. That makes that 5 root 5 with the 3 brought down, which is 15 root 5. Root 15 isn't going to break down to anything significant. Square root of 5, square root of 3, none of those are perfect squares, so we'll just carry that one down, keep it what it was. And then square root of 20 is square root of 4 times the square root of 5, so it's going to be 2 square root of 5 with a minus sign in front of it. Combining our like terms, there are negative 10 and positive 2 of the square root of 15s, so if we add those together, that's negative 8 square root of 15, and then 15 root 5 minus 2 root 5 is 13 root 5 for letter B. Letter C. Notice these are just monomials. I'm not drawing a lot of arrows. I'm just multiplying like parts. So 4 times negative 3 is negative 12. Square root of 12 times square root of 6 is square root of 72. Next step, break down that square root of 72. 4 goes into it, 9 goes into it. Both of those could work, but the biggest perfect square is 36. So this becomes 6 square root of 2 with the negative 12 out front. So then if we multiply those, we get negative 72 square root of 2. Letter D means we need to take negative 3 root 6 and multiply it by itself. Now, those are just monomials, so I'm not drawing a bunch of arrows. I'm just multiplying like parts. Negative 3 times negative 3 is 9, and it is positive 9. Square root of 6 times square root of 6 is 6. Multiply 9 times 6, and we get 54. Letter E. Now, this one does have a binomial times a binomial, so there are a lot of arrows that need to be drawn in this one. Here's our first one. It's going to be negative 5 times 2, because square root of 2 times square root of 2 is 2. Next arrow, that's going to be 5 square root of 12. Now the 8 root 3 is going to distribute. That's negative 8 square root of 6. Take it to the last term. That's 8 square root of 18. Simplifying these each down, negative 5 times 2 is negative 10. Square root of 12 is root 4 times root 3. Square root of 4 is 2. Bring down that 5, so that makes this a 10 square root of 3 for our next term. 6 isn't going to break down to anything meaningful, so it's still minus 8 root 6. Square root of 18 does break down. Square root of 9, square root of 2. The square root of 9 is 3. Then you have that 8 in front of it. 8 times 3 is 24 square root of 2. So now to our answer. None of these have the like square root, so it's negative 10 plus 10 root 3 minus 8 root 6 plus 24 root 2. The order doesn't really matter. None of them can combine, so that's as good as it's going to get as far as simplifying that problem. All right, next example, negative 3 plus square root of 6 squared. This is a binomial, so negative 3 plus the square root of 6 times negative 3 plus the square root of 6. And we have to do all the distributing because it is a binomial. So negative 3 gets multiplied by negative 3. This negative 3 gets multiplied by this positive root 6. So it's negative 3 square root of 6. We'll do this term. Root 6 times negative 3 is also negative 3 root 6. And then at the very end, positive root 6 times positive root 6 is positive 6. When we combine terms, we have 9 and 6 to give us 15. And unlike when we multiply conjugates, this time these two inside terms don't cancel each other out. They're both negative. So negative 3 of the root 6's and negative 3 of the root 6's is negative 6 of those square root of 6's. All right, last two examples, and we're looking at getting square roots out of the denominator. The first one is just a monomial, so no parentheses needed. Just multiply the numerator and denominator both by the square root of 6. That gives us 3 root 6 in the numerator. The denominator is square root of 6 times square root of 6. Divide both of those by 3, and we're left with square root of 6 over 2. The good thing about this answer is there's no square roots in the denominator. Square root of 6 can't break down, and there's no numbers on the outside anymore that can be simplified with each other. Last one, the last one has this denominator, which is a binomial, so parentheses are necessary. We're multiplying by the reciprocal, or excuse me, the conjugate, 5 minus square root of 10. I'll do the denominator first. 5 times 5 is 25. 5 times negative root 10 is negative 5 root 10. Then square root of 10 times 5 is positive 5 root 10. Square root of 10 times negative square root of 10 is negative 10. So because we're multiplying by the conjugates, these inside terms, yes, they cancel each other out. 25 minus 10 gives us a 15 in the denominator. In the numerator, distribute. 5 times 5 is 25. 5 times negative root 10 is negative 5 root 10. Is there anything that goes into 25 and 5 and 15? The answer to that is yes. Divide all of those by 5. So 25 divided by 5. This term divided by 5. And our denominator divided by 5 gets us to here. And that is our simplified answer for that last problem.